Good morning everybody. Today we will be seeing functions. So now what exactly is a function is, let me arrange green board, then we will start writing. So function is kind of, you can assume it to be a machine where in which you give input, it gives out output. Okay, you give some input, it gives us output. Okay, performing some algebraic operations. Okay, so algebraic operations in the sense it could be addition, multiplication, trigonometric function, logarithms, anything. Okay, but function is some machine which takes input and gives out output. Okay, now the input that we try to take is based on some real observations. Like for example, okay, let us say I have started a fruit shop. Okay, now in this fruit shop, okay, what I am going to do is, okay, I am going to make a chart where in which I am selling a number of fruits. Okay, where in which I am selling number of fruits in each day. Now let us say in the first day, on the day 1 I have sold only 1 fruit. On the second day, let us say I have sold 4 fruits. On third day, let us say I have sold 9 fruits. On fourth day, I have sold 16 fruits. Now in this way, if I keep repeating, on some xth day I will obviously produce x square, or I will sell x square number of fruits, right? Now this is observation regarding some experiment. Okay, after doing some experiment we will make some observation. Here what I am calculating is number of fruits. Okay, now observing certain values on some xth day or nth day, I have calculated it to be some x square. Okay, in a similar way, okay, so here your input is x and the output that you are getting is x square. Okay, so basically you are giving input and you are getting output. Okay, so here the algebraic operation that machine is performing is square. Okay, so now this is your basic function. So in general, okay, any function like this is represented by y equal to f of x. Okay, here x is day, indirectly your y is number of fruits. Okay, so this x is called dependent variable. This x is called dependent variable and y is called independent variable. Okay, x is called dependent variable and y is called independent variable. Okay, right? So this is your basic function and this is how a function looks. Okay, now any function in general in maths appears to be in the form of y equal to f of x, like this, where in which, okay, if you change the value of x, y value also will change, and x is called dependent variable and y is called independent variable, and your function is represented as y equal to function of x. Okay, now what is its meaning, I will elaborate. So whenever I write y equal to f of x, okay, then what will this indicate is, or what will it tell us is, okay, it tells us that, okay, it tells us that y depends on x. Y depends on x. That means if I change x, okay, change x, okay, y will change. Okay, you change x, y will change when y is dependent on x. Okay, when y is not dependent on x, you can say y is independent of x. That means y is nowhere related to x when y is independent of x. Okay, so when I write y equal to some function of x, it indicates that y depends on x. So that means you change x, y will change. Now in this change, okay, in this change, okay, there will be two types. Okay, one is delta x and other is dx. Okay, delta x is final value of x minus initial value of x. Dx is when delta x tends to 0, that gap becomes small. This part we will see later anyhow. But remember that, okay, when y is function of x, y depends on x. So if I change x, y will automatically change. Okay, that much if you catch, that is enough. Okay, now if you take a function y equal to f of x like this, and if you try to operate or do some mathematical operation on this, okay, then we will get new functions. Okay, now what are the functions types I will tell you, and then I will discuss in detail. Now any maths function that you take, okay, they will belong to these categories, that is I-late functions. Okay, I will represent inverse functions. Okay, inverse functions in the sense sin inverse x, cos inverse x, tan inverse x, something of this sort. Okay, and L represents logarithmic function. Okay, logarithmic functions, where in which if you take example to this, okay, so if I take example of this logarithmic function, I will have log x, ln x, something of this sort. Okay, and if I take algebraic function, okay, so in algebraic function, okay, you will have, okay, I will write first t represents trigonometric function, t represents trigonometric function, e represents exponential functions, exponential functions. Now all these are, okay, all these are in algebraic functions. Your examples are some 2x square plus 3, some x plus 3, some ax square plus bx plus c, or some linear function combination, anything can be written in, okay, algebraic functions. Now coming to trigonometric functions, you will have sin 2x, sin 3x, cot x, secant x, something of this sort, which we have seen in the previous chapter. Okay, and coming to exponential functions, you will have e power x, a power x, e power some ax plus b, something of this sort. Okay, so now we will discuss each type and model and some basic formulas in this part. Then the purpose of teaching this is actually to learn differentiation and integration. So these logarithms, simple exponential functions and all will be discussed in each slide separately. Okay, so now first we will start with logarithmic functions. Okay, so now first coming to logarithmic functions. Okay, now in logarithmic functions, what will be there, we will see now. Okay, now let's continue. So logarithm, okay, so logarithm is nothing but a function. Okay, what it does I will write here, observe carefully. Now if I have, let us say, a power, okay, what I have is, let us say a power x is some y. Okay, then here this can be written as log of, okay, log of, okay, how I write it is log of y. Okay, log of y to the base a is equal to x. Okay, log y to the base x, log y to the base a, this a is called base. Okay, a is called base. Okay, so we will read it as, okay, log y to the base a is equals to x. Log y to the base a is equal to x. It is read in this manner. Okay, so whenever I write a power x equal to y, then log y to the base a is equal to x. Okay, right. Now similarly, okay, for example sake, if you have 2 cube equal to 8. Then this can be written as log 8 to the base 2 is equal to 3. Okay. Any problem, any doubts, take time, you can understand and then ask me. Okay. So whenever I write a power x equal to y, then I can write it as log y to the base a is equal to x. Log y to the base a equal to x is how it is written as. And if you have 2 cube equal to 8, you can write log 8 to the base 2 equal to 3. Okay. Next. Now for clarity's sake, okay, for example, if I have 3 power 4 equal to 81, then I can write it as log of 81 to the base 3 is equal to 4. Okay. Next, if I have, okay, for example, 2 power minus 3, then that is 1 by 2 cube, that is 1 by 8. Okay. So log of minus 1 by 8, okay, log of 1 by 8 to the base 2 is equal to minus 3. Okay. So this is how you write simple logarithmic functions. Okay. Now you will directly have log, you here first I have taken some mathematical function. Okay. So here I have taken this mathematical function, I have written into log. I have taken this mathematical function, I have written into log. I have taken this mathematical function, I have written into log. I have taken this mathematical function and I have written into log like this. Okay. So all these are called simple logarithmic functions. Okay. Now what is to be done here? We will continue from here. Okay. How to use log. So now in logarithms, okay, so you will have directly some log function like this, where in which you will write log x to the base a equal to m. If you write, then you can exactly think in terms of opposite sense, where your x is, okay, if you concentrate very carefully, okay, your x is equal to a power m. If you have a logarithmic function log x to the base a equal to m, then that will become x equal to a power m. Okay, right. So this term, when it goes to other side, it becomes power. Okay. So I am repeating, this term when it goes to other side, that will become a power m, base power value. Okay, that will give you x. For example, previously we have written log 8 to the base 2 equal to 3, if you remember, or if you check the previous ones. This can be written as 8 equal to 2 cube. Okay, any doubts you can ask me. Okay. So a function like this, where in which if you are given log x to the base a equal to m, then that will become x equal to a power m. Okay, right. Now based on these listed formula, or so far what I have explained, there are some properties of logarithms. Okay, first all those properties, or you can consider, or you can remember them as formulas. Okay. So what are the formulas? I will write here. Okay. So this red is too distracting, I suppose. Okay. I will write properties of logarithms. Okay. I will erase because I have taken a wrong color. So properties of logarithms. Okay. So what are the properties that you have here? We will observe carefully. Okay. So first property, log of xy to the base a is equal to log x to the base a plus log y to the base a. Okay. Alright. Or yeah, that is fine. Okay. Next, second property is log of xy to the base a is log x. Okay, it's not xy, it is x by y. Okay, log of x by y is log x to the base a minus log y to the base a. Okay. Next, third is, okay, log of x power m to the base a is m log x to the base a. And fourth property that you have is, Okay, if you have, okay, I don't have space, I will go for the next slide. Okay, so you can copy this, and then if I go to the next slide, okay, fourth property that I have in logarithms is log x to the base y. If I have, I can rearrange it and write it as log x to the base a whole divided by log y to the base a. Okay, right? Next, log of, okay, log of, very important, log of 1 to the base a, if I write, that is equal to 0. Log 1 to any base is 0. Okay, why it is 0 is, if you take a power 0, a power 0 is what? 1. A power 0 is 1. In fact, any number to the power 0, okay, any number to the power 0 is equal to 1. Any number to the power 0 is equal to 1. Okay, next, if you have log x to the base a, you can write it as 1 by, okay, log a to the base x. Okay, now how you are getting this, I will just elaborate a little, observe carefully. Okay, log x to the base a can be written as log x by log a to some base is some, put it as b, log x to the base b by log a base b, because we this formula we have seen it here. Okay, so that will give you 1 by log x, log a to the base b by log x to the base b. I am just rearranging, that will give you, okay, so that will give you what, 1 by log a to the base x, because base b, if you take common from the previous formula, you can rearrange it and write it like this. Okay, so these are the basic logarithmic formulas that you have here. Okay, right? So now based on this, we will try to solve some problems. Okay, so what are the problems, I will tell you. Okay, now mostly for physics sake, you have to suppose log 2, log 3, all those values later, but we will try to solve some basic questions. Okay, so now let us try to evaluate certain questions, where in which first I will write with question with white color and then answers with yellow or some other color. Okay, so for example, let us consider log of 100 to the base 0.01. Now before solving problems, remember, mug up, okay, mug up all the formulas. Now let us say you have log of 0.01 to the base 100. Now how I will solve this is, okay, this will be what, log of, okay, this will be log of 1 by 100, 1 by 100 to the log of 1 by 100 to the base 100. Okay, so log of 1 by 100 to the base 100. This can be written as log of 100 power minus 1 by to the base 100. Okay, right? So 1 by 100 can be written as 100 power minus 1, right? So this will become what, minus log of 100 to the base 100. Okay, now previously I forgot. Okay, let us go back to this slide. Okay, I have forgot one more formula, that is, okay, log a to the base a is equal to 1. Log of any number to the same number is 1. So that will give you minus log 100, that will give you minus 1. Okay, next, another example. Okay, any doubts you can ask me. Okay, because what I have done nothing new. Okay, here I have applied a formula, that is log of a power m. If you have, you write m log a, that's all. I will not use anything new. Okay, so next, second formula that I would like to focus is, if you have log of 1 to the base some 34, answer is 0. Reason, any number, if I to, as I told you previously, okay, log 1 to the number, if base of any number, okay, any base, if you have, the answer is directly straight away 0. Okay, next, third thing. Okay, the third thing, okay, let us say, okay, you have log x to the base x, your answer is 1. So as I told you previously, or I have written the formula. Okay, Same number if you have, your answer is 1. Okay. Next, let us say, okay, you have, okay, 36 to the power of log of, here what is given is 4 of 6, and you are supposed to give answer to this. Okay, so in this, what are the formulas that you have is, okay, if you have, okay, if you have, I will add one more formula, okay, 8th formula. If you have x power log y to the base x, okay, I am repeating, x power log y to the base x is equal to, okay, this entire term is in power, that is equal to y. Okay, so now according to that, okay, this can be written as 6 square whole power log 4 to the base 6, that is equal to, okay, 6 power 2 log 4 to the base 6, that is equal to 6 power log 4 square to the base 6, that is equal to 6 power log 4 square is 16 to the base 6, that is equal to 16. Okay, so I have just rearranged. Now how to get this idea is purely based on practice. Okay, how many questions you practice, the more number of questions you practice, the more faster you will be able to simplify and learn the ideas. Okay, next, one more example. Okay, now let us try to solve the equation. Okay, the equation is like this: solve log 3 to the base 10 plus log of 4x plus 1 to the base 10 is equal to log of x plus 1 to the base 10 plus 1. Now let us say you are supposed to solve this equation. Now if you look at this question, okay, this part is a, this part is or x, and this part is some y. Log x plus log y can be written as log of xy to the base 10, that is equal to, here 1 can be rearranged and written as log of, okay, 10 to the base 10. I am just rearranging. Now once again on the right hand side also, log a plus log b formula is log of ab. So according to that, you will get log of x plus 1 into 10 to the base 10. Okay, right. Now taking log out on both sides, because both logarithm functions are same, that will give you x into y, that is, okay, here your y is 4x plus 1. So x times 4x plus 1 is equal to x plus 1 into 10. So 4x square plus x, that will give you 10x plus 10. So that will give you 4x square, okay, plus x minus 10x plus 10 is equal to 0. So that will give you 4x square minus 9x plus 10 is equal to 0. Okay, now you have got a quadratic equation. Sorry, x value is 3, right? So I have solved the problem in a wrong manner. Okay, sorry, your x value is 3, so I got carried away because of some call. So 3 times 4x plus 1 is equal to, okay, so I will write this, okay, log of 3 times 4x plus 1 is equal to, okay, 3 times 4x plus 1 equal to x plus 1 into 10, taking log out on both sides. So that will give you 3 4s are 12x plus 3 is equal to 10x plus 10. So 12 minus 2, 2x equal to 10 minus 3 is 7, x equal to 7 by 2. Next, we will try to do one more question. Okay, Now I will try to simplify. Okay, the question is like this: simplify 1 by log of xyz to the base xy plus 1 by log of xyz to the base yz plus 1 by log of xyz to the base zx. Okay, we are supposed to simplify this. Now I will do this question in a different manner. Okay, so idea doesn't strike directly. Okay, it only comes through practice. The more you practice, the more you will be able to do it. Now first formula, as I have told you, if log x to the base y is there, this can be written as log x to the base a by log y to the base a. So according to that, this will be written as 1 by log of xyz divided by log xy. Okay, plus this will become 1 by log xyz divided by log yz plus 1 by log of xyz to the base log zx. So that will become log of, in the denominator, if it is denominator, like if you have 1 divided by 1 by a, you will write it as a. Okay, so that will become log of xy by log xyz plus log of yz by log xyz plus log of zx by log of xyz. So simplifying this, okay, this can be written as log of xy to the base xyz plus log of yz to the base xyz plus log of zx to the base xyz. Now if you have log a plus log b plus log c, you can write it as log of abc. So that will become log of xy into yz into zx plus becomes, if you simplify into a common term, okay, that will become log of x square y square z square. So that is log of x square y square z square to the base xyz. So that will give you 2 log of xyz to the base xyz, that is equal to 2, because log of xyz with log 1 is 1. So log a by log b. Okay, so you will get 2. Okay, next is, okay, calculation of number of digits not required, but if you want you can do it or learn, or else we will try to simplify. For example, next, let us say you are asked to find out, you are given, okay, log 2, log 3, log 4 can be written as log of 2 square, that is equal to 2 log 2. Log 5 you are supposed to remember. Log 6 can be written as log 3 times 2, that is equal to log 3 plus log 2. Okay, if nothing is mentioned, base is 10, of course. Okay, if nothing is mentioned, base is 10. Okay, so if nothing is mentioned, base is 10. Log 7 to the base 10, log 8 to the base 10 can be written as log of 2 cube to the base 10. So that will give you 3 log 2 base 10. Okay, and if you have log 9, okay, log 9 to the base 10 can be written as log of 3 square to the base 10, that is equal to 2 times log 3 to the base 10. Okay, log 10 to the base 10 is anyhow 1. Now why I have given this list is, in this list that you have, okay, you are supposed to remember log 2 values, because in chemistry, okay, your chemical kinetics, chemical equilibrium, ionic equilibrium, you will use logarithmic values, and in physics you will use in nuclear physics and nuclear chemistry. So log 5 and then log 7 values if you remember. Okay, only 4 values if you remember, remaining all values you can derive from these 4 basic fundamental values. Okay, and as of now, okay, the standard value that I remember for log 2 is, okay, log 2 is 0.3010. Okay, and coming to this part, okay, let me try to check in calculator once. I don't remember, but being students you are supposed to remember, right? People like me, we can manage. So if you have log 2, its value is 0.3010 and log 3 value is 0.47712. Okay, so fourth digit is anyhow not required. The 0.4771 alone is enough. Okay, and if you take log 4, okay, so basically it is 2 times కాబట్టి 2 times 0.3010. okay, and coming to log 5, log 5 value is 0.6989. okay, and log 7 value is 0.8450. log 6 value, like we have got previously log 3 and log 4, so you can add it. Okay, and log 8, okay, log 8 is, okay, 3 times log 2 కాబట్టి 3 times 0.3010. okay, log 9 you can derive, so all these values you can get it. Okay, so you are supposed to remember these values. Okay, you must remember. Okay, so don't leave. Okay, so pause the video if required. Okay, and remember all the values. Okay, now based on this, okay, as I have told you, so all these lectures are done. Okay, to explain the basic ideas, and once it is done, okay, you will be given an assignment. Okay, in that assignment you will have more number of questions for practice sake. Okay, so how much you practice, that is up to you, but you have to learn the basics. Okay, right, that's all. Okay, thank you. Okay, now I'll summarize once again. Okay, so what I don't know what formula I have written previously, but okay, so conclusion of whole story is, okay, I have written some formulas. What are those formulas? I will tell you. Okay, so the first formula is, whenever you see something like this, log x to the base a equal to y, that implies your x is a power y, if you have learned things properly. And if you have log a plus log b, okay, to the base x like this, this can be written as log of ab to the base x. Log a minus log a to the base x minus log b to the base x will be log of a by b to the base x. If you have log of a power m to the base x, that will become m log a to the base x. If you have log of, okay, log of 1 to the base of any number, that will be 0 by default. And if you have, okay, log of 0 is undefined. Okay, log of x to the base x, then it is 1. Okay, and the seventh formula that you have is log of, okay, or x power log of y to the base x will be y. Okay, and if you have log a to the base b, then this can be written as log a to the base x whole divided by log b to the base x, which in turn can be written as 1 by log b to the base a. Okay, right, next, and you are supposed to remember, okay, log 2 value is 0.301, log 3 value is, okay, if nothing is given, base is 10 of course by default. Okay, so log 3 value is 0.4771, so 0.4771. okay, and log 4 you can write it from 2 log 2, okay, because log 4 is log of 2 square. So similarly log 5 to the base 10 is, okay, log 0.6989. So 0.6989. Similarly, you can derive log 6, and log 7 to the base 10 is 0.8450. 0.8450. Okay, so this is conclusion. So any simplification that I do based on these final formulas that I have here. Okay, so that's all for today. Okay.